Hello everyone, welcome you all to the another online session of Water Resource Engineering. Today we will start with our third part of the third chapter. In this part, we'll see the earthen dam, basic of earthen dam, then type of earthen dam, and failures in earthen dam. Okay? So in this part, we will cover all the related things about the earthen dam. First, we will see the what is the earthen dam. Earthen dams have been constructed for a long time past. They are constructed with the natural materials. Means by the name you can understand the earth. Means mostly the earthen material like clay material, sand material, rock, which are mostly used to construct the earthen dam. The construction of earthen dam up to 1930 was based mostly on our experience, but now with advanced knowledge of soil mechanism, these dams are designed and constructed. So that means up to the 1930 was based mostly on the experience. Means no machinery, no any tests. So it was done up to the 1930. But now the advanced knowledge and the soil mechanisms are used to design and construct. Okay? And with the increased knowledge of behavior of soil and the development of the moving machinery, earthen dams can be constructed economically even up to the height of 250 to 300 meters. Means earthen dams height up to only the 250 to 300 meters. Okay. And material used for earthen dam is clay material like black cotton soil, silty clay loams, then sandy materials like medium, soft rock, sandy silt, then rock, sand, cement, steel, lime, and other building materials are used in the small quantities. Cement, steel, lime, and other building materials are used only in small quantities. But earthen material like clay material, sandy material, and rocks are used in huge quantity. Okay. Now we'll see the type of earthen dam. Depending upon the method of construction, earthen dam can be divided in three types: homogeneous embankment, zone embankment, and diaphragm embankment. First, homogeneous embankment type. A simplest type of earthen embankment consists of a single material and a homogeneous layer, sometimes a blanket or a relatively impervious material may be placed on a constant basis. Purely homogeneous section is used when only one type of material is economical or locally available. Such a section is used for low, moderately high dams. As the homogeneous dams have lived since the earliest time and used today where only the one type of the material is economically available and they are used for a low or moderate height. Now, zone embankment type. Zone embankments are usually provided with a central impervious coat covered with a comparatively previous transition zone, which is finally surrounded by much more previous outer zone. The central coat checks the seepage. The transition zone prevents piping through the cracks, which may develop in a core. The outer zone gives stability to the center impervious field and also distributes the load over a large area of the foundation. So the load is distributed to the towards the foundations. These types of embankment are widely constructed and the material of the stones are selected depending on the availability. Means the mostly locally available materials are used for construction. Daily drainage materials such as coal, sand, gravels are used for a outer shell. diaphragm embankment. This type's embankment have a thin impervious core which is surrounded by the earth or a rock. The impervious core, called as the diaphragm, is made of the impervious soil, concrete, steel, timber, and any other material. Right-hand side diagrams shown the diaphragm wall, which is mostly made up of either of concrete, steel, and timber or soil. It acts as a water barrier to prevent the seepage through a dam. The diaphragm wall may be placed either at a center as a center core or an upstream face of the blanket. The diaphragm must also be tied to the bedrock or a very impervious foundation material. Now we will see the causes of failure of earthen dam. Following figure shows the failures of earthen dams. There are many types of failures in earthen dams, but the most three main types is hydraulic failure, seepage failure, and structural failure. First, we will see the hydraulic failure. About 40% of the earthen dam failure have been attributed to the causes of hydraulic. Uh, most of the failure of dam that is just because of the hydraulic phenomenon means more about 40% of earthen dam failures are due to the hydraulic reason. Now see the reason behind the hydraulic failure. First, by overtopping. The overtopping of dam may cause due to the insufficient capacity of spillway and insufficient freeboard. If there is insufficient capacity in between the spillway and freeboard, then there is a hydraulic failure by the overtop. Then erosion of upstream faces. Erosion is caused due to the wave action on the upstream slope. If there is a wave action in upstream slopes, means reservoir side, then erosion of upstream slopes failures occurs. Then cracking due to frost actions. Crack in the upper portion are developed due to the frost. If there is a frost in the upper side of the dam, then cracking is happen. It's need to form the seepage and failure. Okay? In the area of low temperature and additional freeboard, if you provide a additional freeboard in a low temperature area, then cracking is happen. Then erosion of downstream faces by gully formation. Uh, Downstream slope erosion occurs just because of the slope on the rain action. If there is a rain action in the downstream slopes, if unchecked and on the gullies downstream faces, then that type of the failures occur. This can be avoided by planting harari. In previous lecture, we learned about the harari. If you plant grass over a downstream faces, then these types of erosion can be neglected. And last one is the erosion of downstream toe. The toe of the dam may be eroded due to the heavy cross current coming from the spillway. If there is a heavy current which flow from the spillway, means from the downstream side, then erosion may occur. Now we see the structural failure. About 20% of earthen dam may failure just because of the structural reason. These are the generally causes by the shear failure. First, foundation slide or overstability of dam, the first reason, and then slide in embankment. Now we'll see the one by one what is foundation slide and what is slide. The first, foundation slide or overstability of the dam. In case of earthen dam on foundation made of soft soil, the entire dam may be slide over the foundation. If your dam is constructed on a soft soil, means like clay or other types of soft soil is there, then uh, this structural failure is happen. Or if there is a fissured stalk, shells, or soft clay, etc. are presented, then also foundation slide or overstability is happen. The top of the embankment gets cracked and subside. The lower slope moves outward, forming large moats near the heel. Uh, right hand side image shows the actually sliding due to the soft or weak foundations. The first condition of the structural failure, that is foundation slide or overall stability of the dam. It is just because of the foundation which is made up of soft soil, and if there is a fissure, soft shells or soft clay are present while constructing the foundation of the earthen dam. Now, second condition, sliding embankment. The embankment may be slide when the slope are too steep. If there is a too steep slope are there, then sliding embankment happens. The most critical condition of the slide is the upstream slope is sudden drawdown of the reservoir, and downstream slope is when the reservoir is full. These two conditions are most critical. First one is a sudden drawdown of the reservoir in upstream side slope, or downstream side slope is when the reservoir is almost full. They generally occur due to the development of the excessive uncounted force pressure, which may reduce the shearing strength of the soil. And many embankment may fail because of the consolidation during or after the construction. If there is a soil consolidation is there, then such types of the failure may occur. These two images shows the actual structural slide in embankment, which is because of the structural failure. First is the upstream slope slide due to the sudden drawdown, and second one is the downstream slope slide due to the full reservoir conditions. Now we'll see the seepage failure. Before starting the seepage failure, first we on about the what is a seepage. Seepage is the flowing of water through the pores of the soil. If there is a continuously flowing water through the pores of the dams, uh, or a leakage in a dam, then it's called a seepage. When seepage takes place through the body of the dam, it is called a horizontal pipe. And if it is from the foundation, then it's called the vertical pipe. Means if there is a seepage through the dam body, then it's called horizontal pipe. And if seepage through the foundation of the dam, then it's called the vertical pipe. Means in easy language, seepage means leakage of the dam either from the body of the dam or from the foundation of the dam. More than one third of the earthen dams have failed because of the seepage. When seepage is controlled or limited, then the dam is safe. Okay? There are various methods to control the seepage. If we control or limit it, then the dam is the safe. However, uncontrolled seepage through the dam body or through the foundation may lead to piping or sloughing and subsequent failure. Uh, First, piping through the foundation. First, piping through the foundation means vertical seepage. Water may start seeping at the huge rate through the highly permeable cavities or fissure or strata of the pore sand or a cavern in the present foundation of the dam. If there is a leakage of water through the foundation of the dam, then it's called the piping through the foundation. This flow at a high gradient may erode the soil, leading to increase the flow of water and soil, creating hollows between the foundation. There is a cavities or hollows uh, create in between the foundation. Dam may sink down into the hollow, so form causing its failure. Now piping through the dam body means vertical pipe. The dam may settle when the flow channels get developed in a body of a dam, removing the soil or leading to the foundation of hollow in a dam body. If there is a leakage to the dam body, then it's called the uh, horizontal seepage. These flow channels may develop due to the faulty construction, insufficient compaction, cracks, development in environment due to the foundation settlement, shrinkage, cracks, animal birth, etc. These are the reasons of the piping through the dam of the body, that is a seepage through the dam of the body. Piping through the dam body generally gets developed near the pipe conduits passing through the dam. The development of the flow channels can be avoided by better construction and maintenance of the dam. If you want to avoid these types of seepage, then uh, better construction and maintenance is the main reason to avoid the such types of failure. Then clogging of downstream flow. This is mostly causes due to the full reservoir condition or highly permeable soil strata are present in the foundation of the dam, permits seepage of water through its causing erosion of soil which result in piping. Slogging mostly happens just because of the full reservoir conditions, okay, or highly permeable strata are present in there. If there is a highly permeable strata is present in a while dam construction, then slogging is happening. Now see the prevention or remedial measure to avoid the failure. First, for prevent hydraulic types of failure, we must do the following measure. First, for overtopping, uh, proper spillway design is there. If you design spillway properly, then overtopping failure may be avoided. Then generous freeboard allowances. Means if your freeboard length is proper or it is limited, then also overtopping is avoided. Or avoiding area where landslide could affect the reservoir. Then proper maintenance of gates and outlets so that they are always functional. Uh, Gates and outlets want a proper maintenance, then such types of the failures may be avoided. Then by wave action, provide adequate protection to the upstream slope by laying riprap in a more substitutional area. If you provide a substitutional laying in the upstream slopes, then such types of uh, hydraulic failures are avoided. Then gully formation of downstream side. Provide adequate downstream slope protection by suitable grass over troughing. We learned about the troughing in previous lecture. Okay. If you provide a suitable grass cover or troughing, then gully formation of downstream slide may be avoided. Then, if necessary, lay riprap protection. Then, for high dams, provide bones and drainage system. We also learn about the bones in previous lecture. Then, if you provide the proper bones and proper drainage, then such types of the hydraulic failure may be avoided. Then, toe erosion. Provide toe drain, horizontal filter at a toe, then we can avoid the toe erosion. Then frost action. Provide extra freeboard of 1.5 meter to take care of the frost action. If you avoid the frost action, then you have to provide extra freeboard up to the 1.5 meter. These are the prevention or remedy measures to avoid the hydraulic failures. Okay, 5 types of the remedies are now to avoid the seepage failure. Keeping the perimetric line well within the dam section by adopting zone section or providing filters at the toe. Okay. Avoiding the development of piping by following correct design and construction procedure. Slogging can be controlled by providing grass cover on a downstream slope. We can also provide a grass cover in a downstream spread by avoid sloughing. Then last one is a structural failure. Structural failure are avoided by following conditions: proper selection of site material used and correct design and construction techniques. Structural failure may occur just because of the if we use the loose soil or faulty soil while construction of dam. If you are select proper site, proper material, then such types of the structural failure may be avoided. Next is the Branson. Investigate the causes of trenching and then fill the restore the dam of the design conditions. The following guidelines should be followed while filling the bridge. Carry out repair work in dry season. Most of the repair and maintenance work must be done in the dry season only. Remove all the loose and poor material from the slide and floor of the bridge. Means, time to time we have to remove that loose soil and proper maintenance must be there. And maintenance work should be done in only dry season. Cut back in a side of the beach to the relatively flat slope. Plug the gap thoroughly so that the repair area is securely founded on the old dam material. Then spreading. Minimize the risk of spreading of the embankment raised by avoiding poor foundation, adopting flatter slope and reducing the height of the dam. If you want to avoid the spreading type of structural failure, then we have to maintain a proper foundation, then adopt flatter slope and reduce the height of the dam. Then such types of the structural failure may be avoided. Thank you.